Welcome and thanks so much for hopping on and joining us for ThreatX first webinar in our SnackAttack series. Today, focused on API protection. My name is Sydney Cafaro, and I'm a product manager here at ThreatX. And partnering with me today is Tony Velti, one of our lead SEs. Tony, if you want to hop on in and say hi, feel free to.
Hello, everybody. Thanks for joining us today.
Not only is this time meant for your team to sit back and enjoy a quick snack on us, but it's also time to hear what trends that are being seen from the ThreatX front lines in our SOC, share insights about how other organizations are solving these common challenges, but it's also time used to put a few friendly faces to our organization. The ThreatX team is going to be following up with questions after the presentation, or you can go ahead and request more time for further conversation by visiting ThreatX.com and requesting a demo. So with that, we certainly have an action-packed agenda, so we'll go ahead and dive on in. Today, we're going to start off by talking about what's being seen in the wild and what type of trends to look out for with the rise of API attacks. But we'll also be talking about how you can protect your APIs from any attack and what to consider when shopping for a solution. And finally, we'll save the best for last and jump into a demonstration of the ThreatX platform and how we take a protection first approach for all web apps and APIs. In this section, we'll start off by reviewing a few trends being seen with API attacks and explain attackers' methodology and how they're evolving their strategies to exploit the new techniques being used in application development, aka the rise of APIs. And we're not the only ones speculating the rise of API attacks. As you've probably already heard, Gartner said by 2022, API attacks are going to be the most frequently used attack vector to target data breaches. So not to scare everybody too much and within our first few minutes, but I think it's an important piece to call out when talking about the evolution of application attacks. First and foremost, I think it's fair to call out that these attackers and hackers are experienced and they're skilled. They know the tripwires and common detection methodologies that are used behind traditional WAF and API solutions. They're staying low, they're staying slow when they're trying to test and discover vulnerabilities in your endpoints, but they're also using every tool in their tool belt to create multifaceted and sophisticated attacks to probe your environment. The second piece is that it only makes sense that the API protection problem space is growing because of the adoption of API-based development over the past few years. According to a survey DevOps Digest conducted, around 61% of developers in all industries said they've used APIs more in 2021 than ever before. So with the growth of an attack surface only comes the evolution of how attackers are designing to exploit it. Lastly, attackers are designing multifaceted attacks to blend together to successfully exploit data. And this really brings us to the last point of how. So for an example, attackers are layering DDoS, credential stuffing, and other botnet type of attacks to distract security teams from the actual data being exploited from their vulnerable or rogue endpoints that are left in production. In the not so distant past, the ThreatX landscape looks something like the tip of this iceberg. Attacks were based off of known vulnerabilities with signatures. You knew how to defend them, and you saw these attacks coming. But now with this attack approach with multifaceted methodology, we're seeing different types of attacks working together below the waterline, morphing over time and really creating this Titanic-sized problem. Today, attacks consist of what's below the surface and are typically a blend of, just like I mentioned, credential stuffing, DDoS attacks, malicious bots, and more combinations of evasion techniques all working together. Defending against only one of these types of attacks is going to continue to leave you vulnerable to the others. And the only way to address this modern threat landscape is to focus on the attackers and their behavior rather than the attack itself. Now, in this section, we'll be focusing on a more holistic view of what qualities to look out for in your web application and API vendors. First and foremost, I'm going to keep beating the drum on really the behavior-based approach and really focusing on solutions that use behavior-based detection methodology versus relying off of signatures or rule-based solutions. By tracking an attacker's behavior over time and looking for suspicious patterns, bad actors are detected more accurately and requires significantly less maintenance, and it results in fewer false positives. Additionally, using point solutions is going to create a disjointed view, and it makes it nearly impossible to get a clear depiction and understanding of these blended attacks. Now, a problem space that's been ever so evident in cybersecurity is the security talent shortage and being able to scale out teams. So even with application expertise, it's important to provide vendors or to partner with vendors that offer managed services and really create that perfect blend between a product and a service. The last point that I'm going to mention, and it's certainly not least, is that using solutions that require minimal deployment is only going to equal faster time to value. So it's not only important to pair with vendors who support flexible deployment options, but it's also important to use vendors whose detection accuracy is able to be turned on and use blocking within days versus weeks. Now, ThreatX takes a protection-first approach to API security, DDoS protection, bot management, all in one unified solution. Our detection methodology is attacker-centric, based on understanding attackers' behavior to protect against these modern threats, and again, minimize false positives without losing the accuracy and visibility that's needed into your environment. ThreatX's single risk engine uses multiple detection techniques, points of observation to capture suspicious behavior, and key insights on who, the what, the when, the where, and how these attackers are starting to target your threat landscape. Now, I understand this is a really scary image, and as it should be, because this represents a 49 million request credential stuffing bot-based attack that we were able to protect our customers against. But we also like to say we were protecting the web apps and APIs that run the world. So with that, I'll go ahead and I'll turn it over to Tony to dive on into the details of the ThreatX platform.
Thank you, Sydney. Appreciate that.
Of course.
Okay, so what we're going to do, I'll just set the stage for you. In the last 24 hours, we have run a number of different attacks. And for the purposes of a demonstration, I'm going to walk you through those. We included cross-site scripting, SQL injection, and then one of our pretty common scenarios that we see live is credential stuffing attacks. So we're going to walk through those and just get you oriented to the dashboard here. See my screen okay?
We can.
Awesome. Okay. So when we first log in, we land on the new dashboard. And as I just mentioned, for the purposes of this demonstration, we're going to look at all of the data from the last 3 days for all of our sites. I'm going to drill into a specific site that we chose to attack, and we'll take a look at both web and API traffic and how we score that traffic and protect it in your environment. So the first thing we see is the max risk score. This score just represents what's coming at you and in terms of the risk level. So it doesn't mean that this risk level is exploited on your side. This is what we're seeing on the ThreatX interfaces of the sensors and are stopping. But it gives you a great bit of visibility as it relates to being able to see now what's coming at you. Without that visibility, you might wonder if you've got a problem with some of your back-end servers, or there might be some other issues. one quick glance tells us that we're seeing some fairly heavy type attack traffic. I'll click to the next tab. We're seeing now all the requests in aggregate for your environment. As you can see, we started doing some attacks and have continued up until just a few minutes ago. And then here are the blocked requests. So this, in essence, is showing you all of the traffic and then all of the traffic that was blocked. This is the stuff that we're interested in. And so as we move down the screen, the very first thing that we see are the threat entities. And currently we have over 1,000. And we see the entity names. So those are names that we just auto-generate in order to make it easier to work with and maybe converse with somebody else about a given entity. And then we see a risk score. So ThreatX uses multiple steps in order to identify an attacker and their intention. So the very first thing we do is when we see a request coming in, we watch that request. And if that request looks like a normal user and there's nothing in it in that request that could be considered an exploit, for example, we see on the top line directory traversal, and this Oracle WebLogic exploit CVE. So obviously bad traffic. And so what we'll do is we will block that traffic and then we'll watch them and see how their behavior continues. In this particular case, they kept doing attack type traffic. So as they continued to get blocked for the bad stuff while we allowed the good stuff, their risk score gradually increases to the point where it passes 70. When the risk score passes 70, that entity receives a half-hour block. A lot of times that half hour is enough time to get, in particular, aggressive bots to think that something has happened, time out, and go away. Doesn't mean that they'll come back later. And if they do, we'll have their history for the last 90 days of everything that they've done. So they don't get to pick up where they left off, even if it's a month or two later. And as we can see here, we've got a variety of different classifications and descriptions, and we also have the geolocation. So when we're doing the decision-making process with regards to their behavior, our engine will look at things like the intensity, the amount of traffic, the amount of time between requests being sent, types of requests, and then the classification of it, and then a full description of it. And we'll also factor in the location. So there are countries, if it's coming from a country that it shouldn't be coming from, that'll get factored into the risk score. This way we weed out false positives, and we continue to track those threats as they continue to attempt to exploit an environment. I'm going to jump over to top targets here. Now, this is a list of all of the sites that we're protecting. We're going to focus on attacktest.com. That is the one where we ran this bubble of attacks. And we're gonna take a look at what's happening inside it. So I click on top targets, I go to attack test, I see that this our site has a threat score of 100. That means that we've got some very interested entities that are attempting 264 entities that in the 3-hour time frame have done over 4,000 requests. Of those requests, we matched on 1,600 of them, and then we blocked just a little bit less, 1,605. We also have a status code summary over here that'll show us all the 200s, the 400s, and then the 500s, so that we get a good understanding of the traffic and whether there are any issues with backend servers or any issues with the application in terms of its response to a given user. And then from there, and this harkens back to the visibility, we can now dig into all of the endpoints that have been requests against them with match events. And let's take a look at reviews. So as I unfold this, I'm interested in knowing what exactly attackers are doing to this particular path. In this case, it's a reviews page, and we see a number of entities. Green, they've done something, but they're being watched. Typically, if we have programmatic access or we have odd headers or unusual traffic, but not yet malicious, we will go ahead and score it. And this score is at 24. They can move up as they continue to do things that they shouldn't be doing until we get to a risk score over 70. And I'll show you that one in a minute. So if we take a look at this entity, I'll just hop over to this tab. We can see full details about that request. So if I look across the top, I've got a rule match with a risk. I'm showing a JSON-based API. This is the domain, the path, and then the method used for this particular request, the user agent, and then we have the parameters. In this case, that is a SQL injection that's being dropped into a search form. We inspected that, and it is obviously a risk. So the score is 70. So we're going to block that request. Let's take a look at SQL injection. Oh, that was cross-site scripting. So SQL injection, again, we're seeing in the search page, SQL injection into a form, again, using the JSON API. We'll take a look at that top entity, and we can see here that this is a SQL injection or a cross-site scripting attack. We've got a risk score of 70, so we are blocking it. I'll hop over to endpoint statistics and show you if we had an application that had mixed non-API and API endpoints, we would see those endpoints articulated or spelled out here. In this case, we're looking at this endpoint being targeted by this via API by this attacker. Oh, sorry, wrong one there. Then the next one we're going to take a look at, and this is another attack that we had just run. I'll show you how we work our way all the way up to ultimately blocking an entity. So with this particular entity, we're seeing a risk score of 100. We see a lot of other ones that are on their way. This is fairly typical of credential stuffing or like layer 7 DDoS attacks where we have a very high error rate. It's obviously scripted and programmatic. Take a look at that entity. And here we see now a whole bunch more volume. We can see that it started to pick up over time, and we'll take a look at responsive actions to see that we have a block. And we're looking at now mixed API and non-API traffic. If we go over to activity, I'll unfold one of these. We'll take a look at it, and we see that we have a risk score of 5. So this is a whole series of these, but because the behavioral engine has factored in intensity, we moved the risk score up, up, up until it got over a 70. This one's at 100. And then the responsive action is to do a half-hour block. Now, we have a 3 strikes you're out process. So this is the first block. They come back, they continue the behavior, they'll get a second, they'll continue it again, they'll get a third, and then after that third transgression, they will go to the blacklist. Let's jump back to the dashboard. As we can see, we've got a mix of all of these different types of sites, both with web and API applications. And we're going to jump over to the API catalog. Now, this is particularly useful because this gives us more information about the APIs and how they're operating. So let's take a look at the user login, API endpoint details. Every time we see API activity, we automatically start to track and catalog it. for every site that we're protecting. In this case, you can see we've got the endpoint profile tags, we've got the methods used, and we've got keys presented, and then the total number of requests, and then the 200, 400, and 500 codes coming back. And we can see we get more detail here that would help us understand more about how the API is not only being protected, but how it is performing. So this is one where application developers or an application owner would be very interested in understanding that. And obviously we have the key pairs here. So with that, I think I will wrap it. I'll turn it back over to Sydney.
Tony, I'm going to hand it back over to you to just talk through some of the specifics of this diagram, because you'll do a much better job of it than I will.
Yeah, thank you. So this diagram has a lot of bits and pieces in it, but it really is a very simple solution if you think about it from a topology perspective. So we look at the ThreatX security container. That ThreatX security container is an ephemeral image that we host in our cloud environment that is auto-scaling and is designed to handle and process all, we call it a sensor, but process all of the data that we're seeing on the screen in a structured manner. So on the left-hand side, we've got the users you want, we've got hackers, we've got botnets interacting with our sensor or sensors. The very first thing that the sensors do is start to profile applications and APIs. With interesting traffic, it may interrogate that traffic, especially in situations where it is programmatic access or a bot. We may push a cookie back to it and see if we can't get more information about that endpoint. We also have the Sql Injection cross-site scripting analyzer engine, along with flow validation, so we can keep track of sessions and timing. And then the layer 7 DDoS protection that we're able to effectively mitigate by identifying bots very, very quickly, and then grouping bots as we see TLS fingerprints into a group, and then moving them through that 3 strikes you're out process on that final block, and then ultimately blacklist. It means that those entities that are attempting layer 7 DDoS aren't going to get the chance to even communicate with your origins. It is also here where we have both behavioral signatures, and of course we can do custom signatures in support of a specific topology application or environment. Next, it gets past the decision engine. This is where we start to classify and score the entities, do correlation among entities, and also do our risk behavior analysis. And we then interact with our cloud down below, analytics, which essentially we can call the dashboard for simplicity's sake. That's where we send the metadata so that we can view it and we can analyze it and take action on it. Finally, the advanced firewall component is full control of the traffic by watching it, blocking it, managing blacklist and whitelist entities, and then also continuing to do any type of interactive response, including, as I mentioned before, interrogation, deception, or even just tar pitting, slowing everything down by 4 seconds. All of this is in front of either your corporate data center, a private cloud, or a public cloud. We can support applications across all of those environments using the ThreatX cloud-hosted security containers.
Perfect. Yeah, thanks so much, Tony, for walking us through that. If anybody does want to have a more dedicated conversation, please reach out to us via ThreatX.com, request a demo, and we're happy to have some conversations one-on-one. Please join us for the next webinar, and we certainly appreciate the time.